Alright, here's problems 21 through 30 on your semester exam review. In the diagram, JM is the diameter of circle N, and PK is 13, and we want to find HP. Okay, so let's look at the information we were given. We have that PK is 13, and we know by definition if we have a diameter and it intersects a chord perpendicularly, it bisects this chord. Well, that means that HP is also going to be 13 as well. And that's our answer, 13. Had it asked for HK, whoops, that's an awful looking line. The whole thing would be 26. But it didn't ask for the whole thing, it just asked for HP, which is 13. Alright, number 22 in the diagram, we have angle J is 39.5 degrees, and we want to find the arc JK. So we want this distance right here. Well, we have an inscribed angle, and to go from your inscribed angle to your arc measure, you're going to take 39.5 and you're going to multiply by 2. Okay? And that's going to give us 79 degrees. Okay, so the arc HK is 79 degrees, but that's not what we're looking for. We know that HJ is half of our circle, which is a total of 180. So if we take 180 minus 79 degrees, we get 101 degrees, which is our answer. Number 23. In the diagram, line M is tangent to the circle at angle O, and angle ABD is 79 degrees. So ABD is 79 degrees. And we need to find the arc measure AB. Alright, so anytime we have an arc measure and it's only 2 letters, that means it's going to be the shortest distance, which in this case is this distance right here. You don't want to go the opposite way. Well, inscribed angles, we know that if we're going from the angle to the arc measure, we have to multiply by 2. If we went the opposite way, we would have to divide by 2. So all you do is take 79 times 2, which is 158 degrees. So the measure of arc AB is 158. Number 24, it says find the value of x. These are 2 secant lines, so this is where you have to do the outside times the whole line is equal to the outside times the whole line. So on this first line, my outside piece is 6. And my whole line, if I add that together, is going to be 10 plus 6. And my other secant line, the outside piece is 8. And my whole line, if I add it together, is going to be x plus 8. Okay, now all we do is combine like terms. So 6 plus 10 is 16. You have 6 times 16. It's equal to, and we're going to distribute our 8, so 8 times x is 8x, 8 times 8 is 64, okay. 6 times 16 is 96, subtract 64 from both sides, and that gives us 32, so we have 32 is equal to 8x, and divide by 8 on both sides, x equals 4. Alright, next example is number 25. It says the equation of the circle is x minus 5 squared plus y squared equals 9. Find the center and the radius of the circle, then graph the circle. Alright, so if we take a look at this x term here, we want to take the opposite side, sine, and this is going to be at 5. And if we look at the y term, we see how nothing's added to it, so our center is going to be at 5, 0. Okay. And we know that 9 is r squared, So if we take the square root of 9, that's going to be our radius, which is 3. Okay, so now we should be able to graph our problem. Alright, move some stuff around so I can actually graph this. Alright, so the point 50 is right here on the graph. We know that the radius is 3, so I'm going to go over 1, 2, 3, put a dot, go up 3, go left 3, and down 3. And then I should be able to sketch a nice graph that looks like a circle. It's not perfect, but you get the idea. Okay, that was number 25. 26. The diameter of circle Q is 14 centimeters. Find the arc length of PR. Okay, so there's two different ways you can actually do this. You can either use the arc length formula, or you can set this up as a proportion. We'll do it both ways. Okay, so the formula is you take your central angle and set it over 360, and you multiply by 2 pi r. Okay, so that's your actual formula if you want to plug your different variables in. Alright, so if we take a look at our picture, our central angle is 34. So that's 34 over 360 times 2 pi. And we're given the diameter, so we have to take that and divide it by 2 to get our radius, which is 7. Okay, so 2 pi 7. Alright, so if you actually plug this into your calculator, about 4.15. Okay. Here's the way you can do it by setting up a proportion. Okay, you can set your central angle over 360, and that's going to be equal to your arc length over circumference. Okay, so our central angle is 34 over 360. We don't know our arc length, so we're going to let that be x, and the circumference, we know we can find that by pi times diameter, which our circumference is 14 pi. And we can set that on the bottom. Okay, by normal cross multiplying, we can set up an equation of 360x is equal to 34 times 14 pi, and then divide each side by 360, and you get the same answer of about 4.15. Number 27 says find the diameter of a circle with an area of 27.2 square centimeters. First thing you want to think to yourself, okay, this is a circle, and what is my area formula? Area is equal to pi r squared of a circle. Okay, we're trying to find the diameter. Well, in this case, we have the radius, so we can find the radius and then find the diameter from there. We're given 27.2 as the area, so plug that in for A. 27.2 is equal to pi r squared. Now we need to get r by itself. Okay, so we're going to divide both sides by pi. And once you do that, the pi's will cancel out. And we need to get rid of this square, so we're going to square root both sides. Okay, so we know that the radius is equal to the square root of 27.2 divided by pi. And you can actually plug this whole expression into your calculator and it will give you your answer. Okay, but notice that this was asking for the diameter. So you have to take whatever you get and multiply it by 2. Okay. Now, when you plug this into your calculator, you should get 2.94, and so your diameter, when you multiply by 2, will be 5.88 centimeters. Number 28, it says find the area of the kite. Okay, so area formula for a kite is area is equal to 1/2 D1, D2. D1 and D2 stand for the whole diagonals. Okay, so if we look at this first diagonal, we only have half of it. This is bisected, so that means that this whole diagonal is going to be 12. And the other diagonal is 11 plus 1, which is 12 as well. Okay, so we're going to plug each of these in. This one will go in for D1, and this one will go in for D2. So area is equal to 1/2 12 times 12. One half times 12 is 6. 6 times 12 is 72. So it's 72 centimeters squared. And because it's area, you have to have square units. Number 29. It says, describe how the change affects the perimeter and area of the figure. Round your answers to the nearest hundredth if necessary. Okay, so first thing you need to do is find your original perimeter and area. Well, to find the original perimeter on this, you're going to have to do a squared plus b squared equals c squared first in order to find your hypotenuse. Okay, so 2 squared plus 20 squared, which is 4 plus 400 is equal to c squared, 404. And to get c by itself, you're going to square root, so our c value is about 20.1. Okay, so if we add up all the sides, we get 2 plus 20 plus 20.1. That's equal to 42.1 meters. Alright, to find the area, that's equal to 1/2 times base times height. So 1/2 times 2 times 20 is equal to 20 meters squared. Alright, so we have our original perimeter and area. Alright, now we have to find our new stuff. Okay, so I'm going to go ahead and get rid of this stuff in the middle. I'm going to get rid of all this extra writing. And I'm going to find my new dimensions. Okay, so I know that if I take the 2 and divide it by 2, or if you multiply it by 1/2, that's going to give you 1. 20 divided by 2 is 10. Okay. And we're going to have to do Pythagorean theorem again to figure out what hypotenuse is going to be. So a squared plus b squared equals c squared. 1 squared plus 10 squared equals c squared. 1 plus 100 equals c squared. So our c should be about 10.05 meters. Okay, so my new perimeter is going to be 1 plus 10 plus 10.05, which is 21.05, and my new area is 1/2 base times height, which is 1/2 10 times 1, which is equal to 5 meters squared. Now, for the perimeter, I'm going to take the 2 and subtract them. Actually, no, in this case, I can take new divided by old. So my scale factor for perimeter, if I take my new divided by my old, so 21.05 divided by 42.1 is equal to 1/2. And my scale factor for my area, new divided by old, my new area was 5, my old area was 20, so if I reduce that, I get 1/4. Okay, so let's get rid of some of this writing so we can actually write our answer. So the perimeter was decreased by a factor of 1/2. 1/2, and the area was decreased by a factor of 1/4. Alright, last problem for this video. It says identify and describe the solid produced by rotating the figure around the given axis. So if we think about this figure, let's look at this one point here. If it's rotated around this axis, it's going to be rotating around in a circle. Okay, so I'm going to draw a little dotted line to represent where this little thing's going to go. Okay, well, if you think about the top corner, it's also going to be rotated in the same fashion. Well, if you have this little line and we map everywhere it goes around this figure, well, you have to think to yourself, what does that look like? Well, to me, it looks like a cylinder. Okay, so this is a cylinder, and if you take a look at the bottom, the radius of the cylinder is going to be 5. And then if you want to know what your height of your cylinder is going to be, that's going to be 10. And that's it for 21 through 30.